And just set it on my desk on that little orangey folder, please. All right. Geometric sequences. Today shouldn't be too bad because I didn't want anything crazy while we had our little pop quiz, which most of you did pretty good on, so I'm excited. If you got a 0 on that, just by the way, that's very foreboding to what your pass rate is going to be for this class. So just letting you know. A geometric sequence. A geometric sequence with an initial condition a sub 1 put that in big letters. A geometric sequence with an initial condition a sub 1 and a common ratio. So a geometric sequence with an initial condition a sub 1 and a common ratio r is a sequence of the form a sub n is equal to a ar, ar squared, ar cubed, and so forth. So a geometric sequence with an initial condition a sub 1 and a common ratio r. So if you want to write that it has two characteristics, it is going to have some sort of initial condition and it is going to have your common ratio r. We have two different ways of representing geometric sequences. What are the two different types of formulas that we talked about last time, that we've been talking about over 9.1 and 9.2? Recursive and explicit. Oh my gosh, you give me so much hope for my job. A recursive formula for a geometric sequence is going to be a sub n is equal to a sub n minus 1 times r. And I'm going to make that n a little bit nicer. And it is going to say given or when a sub 1. So there are two ways that we know something's recursive. What's one of those ways, Emma Price? Looking at this formula, there are two things that are indicating that this is recursive. What are they? Do what? Yeah, a sub n minus 1. Very good. Now, other Emma, can you give me the other one? So not quite. So that's going to be our sequence. Let's see. Jesse, can you give me something? Oh, Ethan. Starting term, a sub 1. So those are the two things that tell us that we have a recursive formula. So now let's do an explicit formula. That is going to be a sub n is equal to a sub 1 times r raised to the n minus 1. So be very careful with your subscripts here, okay? Your subscripts are the ones that go beneath and your superscript. So notice your explicit formula has the subscript of 1, but the superscript of n minus 1. So what's one indicator that this is an explicit formula, Kaden? There's one way that we know something explicit. Do what? Nope, not quite. So that's more of a recursive. What do you think, Olivia? This one's harder to see. It has n as a variable. N is your variable. So that's how you know. All right. Now, identifying a geometric sequence. Now we are going to be given an example, and the example we are going to look at is the sequence 3, 6, 12, 24, and 48. In these questions, it's going to ask you what is A sub 1 and R. So it's going to ask you for your initial condition and your common ratio. The way that we do this, if you'll remember, now don't write this down because this will confuse you. I'm just showing you. If you remember our arithmetic sequence, we added D each time. We remember this? Our common difference. I see some nodding. So what we're going to do this time is we are trying to figure out what are we multiplying by that's the same for each one of these. So I'm going to take 3, I'm going to take 6, and use consecutive terms to try and figure out that common ratio. So Josh, Treese, can you give me 2 consecutive terms? 6 and 3. So I'm going to put the thing that is on the right, I'm going to put that in the numerator, and I'm going to put the thing on the left in the denominator. Okay. It doesn't matter if it's a bigger number or a smaller number. The point is the second one goes over the first one. Give me 2 more consecutive terms, Haley.
6 and 12.
6 and 12. So what am I going to put in my numerator?
12.
12. So I'm going to put 12 over 6. Give me 2 more consecutive terms, Bills.
24 and 48.
24 and 48. All right, we're skipping over here. So we're going to put 48 over 24. And give me the last 2 consecutive terms, Colton. Do what? Look at the pattern. These 2 guys are right next to each other. They're consecutive terms. These 2 guys are right next to each other. They're consecutive terms. 24 and 12. That's okay. Am I going to put 24 in the numerator or the denominator, Colton? Try again. It's going to be the numerator. So the question is, are these things equal to each other? What does 6 over 3 simplify to? Anyone? 2. Oof. What does 12 over 6 simplify to? Anyone? 2. 12 divided by 6 is 2. What is 24 divided by 12?
2.
And 48 divided by 24? 2. Oh my gosh, all these things are equal to 2. So this guy that we just found, that is going to be our common ratio R. So we found R, but it's also asking for A sub 1. So Elijah, what's going to be our A sub 1? Do what? What do you think, Ethan? 3, because that's my initial condition. It's the guy that I'm starting out with. Very good. So let's look at another example. Again, we are trying to find a sub 1 and r. And let's say that we've been given 3, 6, 9, 12, and 15. And we are looking for a sub 1 and r. On your own paper, I want you to do the little trees that we just did. And I want you to try and determine if those are equal or not. I'll give you a couple. So what is this first guy here? Emma Price. Well, so let's start one step before that. What do I need to write right here? 6 over 3. And she went ahead and said that 6 over 3 is equal to 2. All right, Olivia, what do I put next?
9 over 6.
9 over 6. What is 9 over 6 equal to?
3 over 2.
Yeah, it's like 3 over 2, or it's like 1/2. Are these two things equal to each other?
No.
No. So if these aren't equal to each other, what does that mean? That means it's not a geometric sequence. Because there is no common ratio. There's no R. So let's do another example. And you're going to have to think outside the box a little bit with this one, but I think we'll be okay. So let's say that we have 3 raised to the 5th power, 3 raised to the 10th power, 3 raised to the 15th power, and 3 raised to the 20th power. If I'm putting these guys over one another, pick 2 consecutive terms, Beals. Very good. 3 to the 5th and 3 to the 10th. And I'm going to put them over each other. So is 3 to the 10th going to be in the numerator or the denominator, Bills? Numerator. Very good. 3 to the 10th over 3 to the 5th. The next 2 consecutive terms are going to be 3 to the 15th and 3 to the 10th. So I'm going to write 3 to the 15th and 3 to the 10th. And lastly, I've got 3 to the 20th and 3 to the 15th. Are these things equal to each other? Well, instead of pulling out our calculator and getting some nonsense, I want you to think about something. Think about if we have x cubed over x squared. What do we do for that? What is that equal to? It'll just be x. Why is that?
You'll subtract the 3.
Yeah, you'll subtract the exponents. Whenever you're dividing things, and that is a 3 minus 2, whenever you're dividing things, you're subtracting the exponents. So what is 3 to the 10th over 3 to the 5th? It's going to be 3 to the 5th. What is 3 to the 15th over 3 to the 10th? 3 to the 5th. What is 3 to the 5th? 3 to the 20th over 3 to the 15th? 3 to the 5th. Are these things all equal to each other? So my R is going to be 3 raised to the 5th power. Now, what is my initial condition, a sub 1? 3 to the 5th, because that's our first term. That one wasn't too bad. I am going to put up 3 examples, and I want you to try and do them on your own. I'm going to, for those that are still writing, I'll put these examples up here. So our first example is you are going to do 2, 4, 8, 16. I want you to find a sub 1, and I want you to find R. Our next example, I'm trying to put this down a little bit lower, is going to be 1, 5, 9, 13, and 17. Find a sub 1, find R. And hopefully you guys are done writing this at this point, where you are going to have the example of 2 to the 3rd, 2 to the 7th, 2 to the 11th, and 2 to the 15th. And again, find a sub 1 and find r. Where's my little laser pointer? Go ahead. Yeah, let's do it. Okay, so we are going to look at consecutive terms in the sequence. 2 and 4, 4 and 8, 8 and 16. Let me get my little thing so people can hear me. I started watching my videos back and I was like, they can't hear anything I'm saying. And we are going to slow down with our handwriting so we can make sure everybody can read it. You got the answers right, so there's no need to go super fast. And we are going to divide these things and see if we can find a common ratio. So we did 4 over 2, 8 over 4, 16 over 8. And were those equal to each other, Nathaniel? Yes. Okay. What did they equal? 2. Very good. So what does that mean? I got 2 over and over again. So our first term in our sequence was 2 because we had 2, 4, 8, 16. And then our common ratio is also going to be 2. All right, do the next guy in blue. You can do all of them, Professor. Ooh, do the lighter one. You won't be able to see. Thank you. So we pick consecutive terms. Colton, give me an example of consecutive terms. 5 and 1. Yep. So we did 5 divided by 1. He did 9 divided by 5. And those are not equal, right? Because 5 divided by 1 is 5. What's 9 divided by 5? I think it's like 1.8 or something like that. So it is not a sequence. You can just put no in big letters. Yeah, okay, that works. All right, let's do the next one in orange. So you have 2 to the 3rd power, 2 to the 7th, 2 to the 11th, and 2 to the 15th power. We're going to find consecutive terms. Jesse, name 2 consecutive terms. 2 to the 3rd, 2 to the 7th. Those are right next to each other. And I'm going to say 2 to the 7th over 2 to the 3rd. 2 to the 11th over 2 to the 7th. It's harder than it looks, isn't it? And then lastly, we'll have that 2 to the 15th over 2 to the 11th. So Josh, Trace, are those things equal to each other? Yeah? What are they? 2 to the 4th? What is 2 to the 4th? R? What's R represent? What is the name of R? At the beginning at the beginning where we had our definitions. What do we call that? Common ratio. Very good. So Beals, what is a sub 1? Did be 2 to the 3rd power? What does a sub 1 represent? R represents common ratio. So what does a sub 1 represent? The starting term, initial term, first term. Very good. Look at you. You got it. Very good. Thank you. You're really good at like systematic thing, like sequences and like the inverse equations and stuff like that. You're super good at those. You're really fast at those. All right, cool. So let's do things that are a lot harder. Let's analyze a geometric sequence. Let's figure out how we can create an equation to represent this geometric sequence. So let's do it. It'll ask you a question and it'll say, what is the 10th term of a geometric sequence? So what is the 10th term of a geometric sequence? The example that we are given is 4, 12, 36, and so on. The first thing that we need to ask ourselves is, are we going to use an explicit or a recursive formula? So you're going to use a recursive formula whenever you've been given some sort of consecutive term, but we haven't been given any consecutive term to the 10th term, right? We've been given the first term, the second term, and the third term. So if we try to do a recursive formula, that would take forever. We would have to find the 4th, 5th, 6th, all the way up until the 10th. So in these cases, whenever you haven't been given a consecutive term, you've just been given it from the beginning, you're going to use an explicit formula. And it'll make more sense whenever I do an example with the recursive formula when you'll use a recursive formula. So on your own paper, what's the common ratio? Whenever you have it, you can just shout it out. 3. So you take these guys, do 12 over 4, 36 over 12. These guys are both equal to 3. So in this case, R is equal to 3. And our next question is going to be our initial condition. So what is my initial condition? It's going to be 4. All right, if I'm using an explicit formula, let's identify what formula are we going to use. So what formula? At the beginning of class, I gave you guys a recursive formula and an explicit formula. Why don't you look back and see what our explicit formula is going to be? Yeah, now that's an arithmetic, right?
I sub n.
I'm proud of you for remembering all of that. But go ahead, Olivia.
I sub n equals a sub 1 times r to the n minus 1. I don't know how to say that.
A sub, okay, so it's a sub 1 times r raised to the n minus 1, right? So let's see if we can figure out what things we can identify. All right, I don't know what the 10th term is. I'm trying to find the 10th term. Another way of saying the 10th term is saying that exactly, is that it's going to be n. So we are trying to find a to the 10th. So I don't know what a to the 10th is. So a sub 10, I'm going to put it right there. We already identified what our initial condition was, a sub 1, and that was going to be 4. We're multiplying that by r, and we decided that r was 3. Now, what is my n? 10. Very good. So I have 10 minus 1. So anyone that has a calculator on them, if you want to toss that in the calculator, we have 4 times 3 raised to the 9th. I'll go. It's really big. Yep, 78, 73, 2. It can get out of hand really quickly. So what is that number? What does that mean? That's the 10th term in the sequence. That's the 10th term. We'll do another example. I'm just trying to go through different directions that you'll probably see. So let's do another example. That is asking you to find the second and third terms. So find the second and third terms in the sequence. You're going to have 2, there's a blank, there's another blank, and there is negative 54, and then the sequence continues. Now, if you'll remember, and this kind of confused a couple people last time, but maybe we'll get the swing of it. If you remember, don't write this part down. This is just showing you. For our arithmetic sequence, we did this thing where we said, all right, 2 to get to the next term, we added some D, and to get to the next term, we added some D, and then we added some D. Again, don't write that part down. Do we remember that? And we created a formula. Well, the difference is now we're doing a geometric sequence where we're multiplying things, right? So we're multiplying something by 2, some common ratio to get a number. Then we're going to take that number and we're going to multiply that number again by R to get the next number. And we're going to take that number and multiply it by R in order to get negative 54. So I'm going to have 2 times some R times R again times R one last time is going to be negative 54. What is R times R times R, anyone? R raised to the third, R cubed, very good. So this is going to be 2 times R cubed is equal to negative 54. So what do you want to do first, Elijah? Yep, so we combined our R's. Yes, come in.
I know that's what the sign says.
Oh, that's usually like for my planning and stuff, but that's okay. How are you? I'm sorry, what was it, Elijah? Divide by 2. So if we divide both sides by 2, then I'm going to have what remaining? What am I going to write here, Olivia?
R cubed.
R cubed is equal to what? Negative 54 divided by 2. Anybody?
28.
Try and do it in your head. Yeah, look at you. It's going to be 28. Oh, not 28, 27. And it's going to be a negative. This is why I shouldn't just copy what you say. Here we go. So what are we going to do? What are we going to do to solve our R cubed? Cube root it. Look at you, Jesse. You got it. So I'm going to go ahead and copy this step down again because I know sometimes whenever I would look back at my notes, I would get really confused how we move from one step to another. So at this point, I'm going to cube root it. So you put a little 3 there and you cube root. Let me see if we can see this better. All right, so a lot of you guys could get the number that was going to be next, right? But like explaining how you got there was kind of hard, kind of confusing. Let's take a look and try and see how we would create a formula to try and find our common ratio. So what do we think? Does anybody have any ideas? Want to do first?
Pretty much just like flip it around so it's like
It was easier for you to have like the smaller number on the left, right? And you can do that, but you'll have to like invert your answer. So ultimately it'll probably make it more confusing. Let's see how to do it whenever the bigger number's on the left and the smaller number's on the right. Because actually like almost half of you guys did that in here. So that's fine. Don't worry. So let's look at it this way. Let's try and do the exact same thing. Yes, thank God.
Looks like only like 4 front pages. The rest are back.
It's wonderful. Can you bring it here? Let me see. See how it turned out. Hey, this is front and back.
I didn't check this one.
Yeah, this is weird. Oh my God. All right, that printer is fired, man. These actually turned out okay, so this is fine. Okay, so let's do it the exact same way that we did the last problem. All right, we had 48, and if we multiply 48 by something, and then we multiply that number by something else, we're gonna get 3. So if I have 48, and I'm going to multiply 48 by something, I'm going to multiply it by something else in order to get 3. Several of you did this, and that's very good. R times R is what?
R squared.
R squared. So we have 48 R squared is equal to 3. So what do I need to do to solve for R? What's the first step?
Divide 3 by 48.
Yep, divide both sides by 48. That's the like non-intuitive part of it, right? You're like, why am I not going the other way around? Why am I using such a big number? But it'll come together in the end. So I have what left? R squared is equal to what? What's 3 divided by 48? Anybody?
It's like 1, 0.
We're not doing decimals. Three divided by 48. What's 48 divided by 3? 48 divided by 3 is 16. So 3 divided by 48 is
1/16.
1/16. That's going to be 1/16. How do we solve for R?
Square root.
We're going to square root it. And again, I'm going to write this in an additional step. So I have R is equal to, now the square root of 1/16, I'm going to write this extra step, is the same thing as the square root of the numerator and the denominator. If you remember those rules from, I think, chapter 6 or chapter 7. What is the square root of 1?
1.
What's the square root of 16?
4.
So our common ratio is 1/4. Yeah. So Jesse, whenever you inverted it, you probably got your common ratio to be 4, didn't you? Yep. But see, so you'd have to invert it, and so it'd have to be 1/4 instead, because you're going in the opposite direction. So if I look back here and I've got 48 blank 3, and I had those directions still, what is 48 times 1/4? It's going to be 12. 48 times 1/4 is the same thing as 48 divided by 4, which is 12. Ta-da! You have your last guy, and then you're going to have some time to work on your homework in class. So this one is going to be, we are asked to find the 6th term in the sequence. We are given a sub 5 is equal to 12 and R is equal to 0.5. If you remember at the beginning of class, whenever we were trying to decide if we're going to use an explicit or a recursive formula, I said you're going to use a recursive formula if you're ever provided a consecutive term. Isn't a sub 5 a consecutive term to the 6th term?
Yes.
So since we have consecutive terms, that means that I'm going to use a recursive formula. So what is my recursive formula, anyone?
A sub n
Mhm.
equals a sub n minus 1 times r.
A sub n is equal to a sub n minus 1 times r. So if you remember with recursive formulas, it's whatever the big number and the little consecutive pair is, and the smaller number or the previous number in your consecutive pair. So the next number, the sixth term, we have a sub 6 is equal to a sub 5, so the preceding term, times r. What is a sub 5? 12. What is r?
0.5.
So a sub 6 is equal to 6. You'll have a question that'll ask you to have the same directions, find the sixth term, but instead your instructions will give you a sub 7 being equal to something. Yeah, so instead what I'm going to be doing is, again, I'm going to use my a sub n is equal to a sub n minus 1 times r formula, but I'm going to use the larger term, a sub 7, and then the term behind it in the sequence, so a sub 6 times r. So just because I'm trying to find a sub 6, that doesn't mean that I'm automatically going to put a sub 6 in here. You have to see which term it is in the consecutive pair. Is it the first one or is it the second one? So what is a sub 7?
18.
What is a sub 6? I don't know. What is r?
7.
Do we know how to solve this?
Divide by this on both sides.
Yeah, we divide both sides by 3. So a sub 6 is equal to what?
6.
Wow.